recording. Nice. So at ZenML, what we've done recently, I will share my screen, is release 0.10.0, 0.10.0 essentially. And it features a lot of new features that everybody in the community has been asking for a while. And one of them is Kubernetes orchestration. So as you know, like ZenML pipelines can be orchestrated on many different orchestration systems. The classical ones are Airflow and Kubeflow, but recently we've started adding a flurry of orchestrators. And we have GitHub Actions, you might have seen in the last week's community meetup. And today we are very excited to talk about Kubernetes, because Kubernetes is sort of a basis for many orchestration systems. Classically, Kubeflow, of course, everybody knows Kubeflow is built on top of Argo, which runs on top of Kubernetes. And one of the problems that we saw with the Kubeflow orchestrator, even though it's fantastic, Kubeflow pipelines in particular is great, it's a bit heavyweight. So I'm going to be talking basically, by the way, about this blog that Felix wrote, and I'll pass the mic to him eventually. But this blog goes through one of the main reasons why you might want to use the Kubernetes orchestration rather than Kubeflow. Kubeflow pipelines alone requires a list of 21 other packages aside from Kubernetes. So it's quite heavyweight to manage and upgrade and all those things. It includes a UI that you might not need, right? So you might not want to look at the UI, or you might just want to have a different sort of UI for a different cloud provider. And most importantly, you don't need to set it up and manage it, configure it. So that's one of the reasons where you might want to use the lightweight Kubernetes orchestrator that we released rather than the one which is Kubeflow. So, right. So now let's say that you have already decided that you're going to run ZenML pipelines on the Kubernetes orchestrator. What do you need? The first thing you might need is to understand what the orchestrator is about, right? So what are the other stack components that the orchestrator needs? So we have AWS. So the example that we portrayed is on AWS, but in Kubernetes, it's cloud native. So you need essentially a few moving pieces. You need a container registry. If you're on Amazon, this can be a managed container registry like ECR, Elastic Container Registry. You need classically a remote artifact store like S3 bucket on Amazon. And you need a metadata store as well, because ZenML needs a metadata store, and that's just a MySQL instance. And that, luckily, because you have a Kubernetes cluster, that's the last thing you need, a Kubernetes cluster, which can run on a managed Kubernetes service like EKS. You can actually provision the metadata store inside the clusters, very similar to how we can, Kubeflow has a provisioned metadata store as well inside its own cluster. And then everything should work as normal. So you could then add Celdin to it, MLflow to it, other cool things to it, and everything should be working. And that's what we'll see today. Before we dive into the demo, one big thing that we're very excited about here at ZenML, and of course, something where I'm very happy that the team from Fuzzy Labs, now both of them with Matt as well and Tom are here, who are helping us with this. We are releasing, or we made a soft release of the MLOps stack recipes event. And what are these recipes? So these recipes are a quick way to provision resources for different MLOps stacks that ZenML supports. And they can be, we're designing them in a way that you don't need to use ZenML to run these. So they're a bit independent product. We'll talk a lot about these in other community hours, so I won't go into the detail, but you can see that if you go to this URL, I'll post it in the chat. Give it a star if you can, or if you want. It's a bunch of Terraform scripts that quickly provision all the infrastructure you need for the example that we're going to see today. So it does the container registry, it does the S3 artifact store, it does the ML metadata store and all those things. So yeah, and that's what I used before coming on. So all you have to do is clone the repository, go into this folder, edit a few things for your configuration, then do Terraform init and Terraform apply. For those of you who don't know what Terraform is, it's a very popular infrastructure as code tool, which allows you to provision infrastructure as code. Very simple. Right. So from there on in, we go into ZenML territory, and now we're going to actually run an example which trains a model. And I'm going to hand it over to Felix to demo that. Felix, go ahead.
Sure, thanks. I will also share my screen. Okay, so as Hamza already explained, we have those awesome stack recipes now that allow you to very easily spin up those resources. And actually, that is exactly what I have done here. So I ran a Terraform script to spin up all the infrastructure we saw above, like a ECR container registry, an S3 artifact store, and also an EKS cluster, all inside AWS. And now if I do here ZenML stack describe, we can have a look at that stack. So this is also explained here in the blog in a bit more details. After setting up those resources, we would, as usual, like first here is an example file. What we do here is basically we load data, check it for training serving skew using our facets integration, train a simple model on it, and evaluate it. And this code block I have already saved here locally in a run.py file. And then after that, I installed ZenML with the respective integrations that are needed and registered these infrastructure components that we just set up in a ZenML stack, which is this one. So here we can see the ECR registry, we can see the S3 store, and in particular also a Kubernetes store as a metadata store and for the orchestrator.
Nice. So Felix, as a question to you, so these two stack components are the new additions to our arsenal of stack components. So
yes, exactly. I guess I should explain that in a bit more detail. So those two are what we have now newly released with the last release, 0.10. So the Kubernetes orchestrator allows you to orchestrate your ML pipelines inside Kubernetes, similar how you could do it with Kubeflow, as Hamza already explained. But Kubernetes is native, so it only uses the Kubernetes API, no other packages required, very lightweight. And then the Kubernetes metadata store is a new metadata store we added in addition to that, which allows you to very easily spin up a metadata store inside your Kubernetes cluster. And I can show you that in a second. So if we use kubectl now to have a look first in our pods or our cluster. So here we can see already a bunch of pods running, which were actually spun up by this Terraform script. So this also installed Zelden and other things that we are not going to use for this example, but we can see the pods here. But so far, nothing from ZenML. But now if I take this, I already have those, the Kubernetes metadata store and orchestrator in my stack. So what I can do now is simply call ZenML stack up to provision all the resources in my stack. And this will now hopefully provision a metadata store deployment inside this Kubernetes cluster. So this might take a few seconds since it is spinning up a deployment inside there. So that looked like it has already created the pod, and now it is just forwarding the pods to my local machine so that I can also reach it from here later. Now it looks like everything is functional. So if we do kubectl get pods again, we should now see here is in the ZenML namespace, we now have a MySQL pod running. And this one has a MySQL database on it, which we can now use to store our metadata. And now after this, continuing with the guide, basically the only thing that is left to do is calling run.py. So this is the file I just created before. Now let's see how it goes. So what this will do first, it builds a Docker image, which contains the ZenML code, which includes the ZenML code as well as the pipeline that you want to run. So in this case, this run.py, and pushes this to the Amazon container registry. And this is needed because in order to run things in Kubernetes, you need to have everything packaged in a Docker container. And this is building the images for it and making it available to the cluster data.
Felix, we have one question from Tom. How resilient is that MySQL instance? Does it use a stateful set?
To be honest, I'm not entirely sure what a stateful set is, so I would have to get back to that maybe after the call.
I think that I would maybe answer that it's not using a stateful set, and it's very not resilient. so it's not something that we intended for production. It's just something to easily spin up this this particular constellation of the stack, and we rather would have you use a managed MySQL instance like Amazon RDS or Cloud SQL on Google, or the equivalent on Azure, because that's the most resilient way of actually storing your metadata if you were to run it in production.
Yeah, I suppose this is more of a proof of concept than a production setup. Yeah, that makes sense.
Yeah, thanks.
I think you probably can pass some config. I don't know how you spun up MySQL here, but you can probably pass some config to it to use a resilient backend, which might mean that you don't need to use a managed service from the cloud provider.
Yeah, I was wondering, Tom, what is your advice on that? Do you think that usually databases which are so mission critical, such as the metadata store, should live on a potentially ephemeral Kubernetes cluster, or what would be your advice to your clients?
Yeah, I wouldn't normally. I'd normally let the cloud provider manage that, and use the state. If you have to store state within Kubernetes, it's more your own applications, your microservices, stuff that you're not going to, kill yourself over if you lose the data for. It's a matter of preference, though, really.
Yeah, absolutely. I think that we've never, like all these managed metadata store instances, we haven't really seen people running them in production within a Kubernetes cluster. So even the Kubeflow one that you have, it's just to test it. But usually when you're running Kubeflow properly, you're using a managed MySQL outside to store the metadata. As Matt said, if you can avoid state in Kubernetes, all the better. I completely agree. It wasn't really made for that. Nice, Felix. Sorry.
Yeah, thanks for explaining that. I think that's a very important point. So this is mainly intended to just quickly get started and run your workflows on it, try it out. But as Hamza said, managed services definitely are the better production-ready choice.
Nice.
Yeah, so right now it still takes some time to push the image. That is taking unusually long. Might still take a while.
I think it's because it's a big image, but can you perhaps go through the code that we're actually deploying? We didn't get the chance to take a look at it while it's running.
Sure, the run.py, or actually maybe the guests can also, if you already have questions, or otherwise we can go over the run.py quickly.
Just a very quick one. How does ZenML know which Kubernetes cluster to apply the stack to?
Yeah, this is when you set up the stack, you need to configure this in the orchestrator. So, okay, unfortunately, I haven't run it here. So here, for instance, this is the details of the orchestrator, and this orchestrator has a Kubernetes context variable, which I have now defined as Terraform, which is an alias that points to this EKS cluster that we are using.
Got it. Okay, thanks.
Yeah.
Yeah, then maybe to go back to the run.py. So what we're doing here, First, we're just loading some training data. I think that's very similar to the other examples we have. Basically, the digits data set and split into training and test sets. Then we are training a model on that, which is a support vector machine classifier. In the next step, we are evaluating that model on the test set to compute an accuracy. And additionally, in parallel, we are checking whether the training and test data have some sort of data skew between them. Yeah, to be honest, Matt, I'm also not, Hamza wrote this. I'm also not 100% sure what's going on here.
Yeah, I mean, we ran this so many times. It's the curse of the live demo. So I don't know why the image isn't being pushed. Maybe
I think that's this is something we are using US East, and this time around, I always have issues pushing my Docker images there. I think the traffic just starts picking up around this time.
Yeah, I didn't know that it was such a big impact.
Yeah, that's a bit unfortunate.
Yeah.
I mean,
But
maybe
perhaps,
meanwhile, should we go back and talk about what should happen?
Yeah, I think you have some visualizations in the blog, right? So I can, if you want, I can share them.
Yeah, I think if you want, you can take it back, or I can show it here.
No, I can take it back. Maybe you can also play around then.
Okay, let's see if the Docker still goes through in the meanwhile.
All right, so we're unfortunately, while we're waiting for the demo to go through, I mean, at the end, what's going to happen is very simple. There's going to be a master pod. Maybe I go back to this. Yes, here. So you see in this image, we see what essentially is the implementation of the orchestrator. So you have one pod, and that pod is the orchestrator pod. Internally, that's what we call it. It's the master node that orchestrates then the steps. And every step then has their own pod. And this is using the K8 batch API natively. So for those of you who know, these are just, it's quite easy to run these batch jobs. And the orchestrator, what it does is it goes through the topological order of the pipeline step by step and launches like sometimes in parallel, if they can be run in parallel, and sometimes in sequence, the steps. And every step gets its own pod. It has its own entry point, and that entry point loads in the step, so the function that the user defined, and executes it. And then it just goes through and eventually stops until, and when the orchestrator job figures out that all the pods have run successfully, it also cleanly exits and shuts itself down, and we go back to the local machine where you see a successful pipeline run. So the cool thing is that the metadata store is already forwarded to your local machine at this point. So you can then get pipelines and get steps and all those things and materialize things locally. So I think what we see in the blog post is that this example is using facets, which is another great integration that shows statistics of the data frames that are being trained. And you would see a visualization like this, which is all in your, so this actual HTML is stored in your S3 bucket. And where it is, it's stored in the metadata store in Kubernetes. But locally, you can access it like it was on your local machine. Yeah, and I think what Felix wanted to probably show you is this.
Actually, it just started.
Okay, nice.
I think now we can see something live. Better late than never. So now it just started up. Yeah, we can see the 1 second if we go up. So here is how the full logs would look like. First, the logs that we saw for a long time of building the Docker image, and then afterwards, after it has successfully built, it would start up the pipeline. First, it would start the pod of the orchestrator, which then figured out in which order to run the steps, starts each step at the respective time when it can be, as soon as it can be run. And then after everything is completed, also pipeline completion is reported as usual. And yeah, and then here we can see also the pods in kubectl, and you can interact with it. Also there is like some labels attached to them, so we can get, I think it's called Kubernetes sample pipeline, for instance, to get exactly the pod we created just now. And yeah, that's basically it. I think we're already at the end of our community hour, so I would love to still give maybe a few minutes to you guys to hear maybe your feedback on it, if you have suggestions on how to improve it, or also just how you personally would like to use Kubernetes with MLOps.
Nice. Thank you so much, Felix. All right, so I would open it up to the room. I know that it's we're out of time, but we can always stick around for a few more minutes. So, like now that you saw a complete pipeline run, do you guys have any thoughts, or do you like it? Do you not like it? Do you think this is a useless orchestrator? Do you think it's a very useful one? Would open up the room.
I think in principle it's a great idea. It's great to see the demo. I was curious, the orchestrator, that pod you've built that then runs the pipeline, that's a custom component you've put together?
Yeah.
Okay. Yeah, no, I think it's a great idea. I was curious about I know Hamza, you've spoken to Alex at Bodywork, because he has a native approach for Kubernetes. I see you smiling. What's the difference between how he's done it and what you've done here?
Yeah, so this is a very nuanced and fantastic question. I think the cool thing is I had an email thread with Alex throughout the development of the Kubernetes orchestrator, and I sent it to him yesterday. He wanted, so when we first talked, like through you guys, actually, you introduced us.
Matt tried to do a matchmaking.
Yeah. So it was good matchmaking. I think first of all, it's a fantastic project. He's a great guy. I think that with Bodywork, they have a fundamentally different way of dealing specifically with images and how they run these jobs on Kubernetes. So they have more of a pull mechanism on how the code. So they have a GitHub repository, and that GitHub repository is pulled into pre-baked images. So I would say, the whole mechanism of actually orchestration is flipped around on its head in Bodywork, and I think that's a great idea. It's just that that's not compatible with how ZenML does it, because ZenML pushes images and builds images in a slightly different way. The way that our projects could work together is initially the idea was that we would use the internal the Kubernetes API that Bodywork had to actually provision these resources, but right now we took a lot of inspiration from that code, but we haven't really used it. So yeah, I would say just two different approaches. If you have like a less fluctuating image in terms of requirements and environment, you could probably also use Bodywork, and perhaps there would be a Bodywork orchestrator with ZenML in the future. And if you're testing and you have different requirements and different stacks, then you might want to use ZenML's Kubernetes orchestrator. And of course, ZenML also gives you all the other integrations that you might want to use.
Yeah, I love the dream. I mean, obviously, two great open source products. You seem so close, but then you've not quite met in the middle. So it'd be great if there was some overlap, because then you've got the dev resource of both to collaborate and work together.
Absolutely.
But yeah, I think this is the way. I mean, I think not using Kubeflow and these heavyweight things is definitely the way to go.
Yeah. I think in the future, like perhaps casting an eye to the future, what we would like to do is we could have even native orchestrators, which are even outside of Kubernetes. So we had a GCP VM orchestrator, which we hacked together once, where the whole pipeline basically ran on a VM on GCP, or it could be AWS. And there are many teams out there where that's sufficient. And it's just, you don't need such a big pot as we read from Jacobo. So I think like the goal of ZenML is to enable all sorts of teams of all different sizes, and these smaller orchestrators are definitely useful to make us go towards that. All right. So any more questions? We have Kachukul or Ketan. Any comments from your side? Otherwise, we can also wrap. And I mean, I can also stop recording if. So for those of you who are seeing on stream or on YouTube, goodbye.